Hello everyone, welcome to today's class. Let's continue with our topic trigonometry and let's continue with the identities part. So far we have done a plus b identities. Now although I categorize it as a c plus d, but there is no such thing as c plus d. The idea is to convert any sum or difference to product. Okay, I'll explain what I mean. Okay, so idea is to convert anything known as sine C plus sine D. Now I'm not using A and D so that you don't get confused with the A plus B identity. In the A plus B identity, sine is in the A plus B is in the bracket of sine or cos, whereas C and D they works in two different sine or cos. So sine C plus sine D, it is equal to 2 sine C plus D by 2, means you add the angle and divide by 2, cos subtract the angle divided by 2. Similarly, sine C minus sine D is 2 sine. Now this time subtraction is there, so do subtraction first. C minus D by 2 cos, reverse it, C plus D by 2. Okay. Same way we can do it with cos also. Cos C plus cos D. This is 2 cos C plus D by 2 cos C minus D by 2. And last one, cos C minus cos D. Put a star on this identity because slight variation is there. It is minus, first of all, 2 sine C plus D by 2 sine C minus D by 2. Okay. In few books you might see that instead of C minus D by 2 they write D minus C by 2, but then they don't put the negative sign. So I prefer this, that remember that there is a negative sign in the last one and rest everything is in the pattern C plus D by 2, C minus D by 2. Everything you have to do like this. Now the question for this identities will be very straightforward. So how will you know that you have to apply this identity? Because the question will indirectly ask you to do it. Look at the first example. Okay, first one, let's slightly increase the size. All right, now it is saying cos 9x minus cos 5x. First of all, there is subtraction going on, so we cannot do anything apart from directly applying this property in the numerator as well as in the denominator. And we have to prove that this is equal to minus sine 2x cos 10x. Let it be, let's apply it. So first of all, in the numerator this is cos C minus cos D. Let's apply it. So this is 2 sine with negative sign. First of all is add them, divide by 2. So 9x plus 5x, add them, divide by 2. Sine, subtract them, 9x minus 5x divided by 2. And in the denominator also, sine C minus sine D. So 2 sine, add them, not add them, subtract them, 17x minus 3x divided by 2 cos 17x plus 3x divided by 2. Okay, so that gives you 2 cancels. So where there is a negative sign, so this is 9 plus 5, 14 by 2, so you will get 7x. So sine 7x, this will become sine 9 minus 5, 4 by 2 is 2, so sine 2x. Denominator again 17 minus 3, 14 by 2, sine 7x. 17 plus 3, 20, 20 by 2, 10, cos 10x. So sine 7x cancels, so you are left with minus sine 2x upon cos 10x. So straightforward application. Okay, If the question is given in the form of sine something plus sine something or cos something plus cos something, of course you have to apply this property. You have to go from sum to product. That's the idea. Sum or difference, and you have to convert into product. So direct application. Now there are a lot of questions based on these ideas. So let's practice that. Okay. Second question, again same thing. Sine C plus sine D is in the numerator. Cos C plus cos D in the denominator. So sine C plus sine D, 2 sine, angles are added and then divided by 2. So I'm doing this time directly. 5 plus 3, 8, 8 by 2, 4x. Cos, subtract them, 5 minus 3, 2 by 2, only x, upon 2 cos, add them, 5 plus 3, 8, 8 by 2, 4x, and subtract 5 minus 3, 2x by 2, x, cos x cancel, 2 cancels, sine by cos becomes tan 4x. As simple as that. Okay. Next one. Okay. Same thing. This time instead of C and D, they are using x and y. So C, D. Okay. So sine C minus sine D, 2 sine subtraction, x minus y by 2, cos addition, divided by 2 cos x plus y by 2, cos x minus y by 2. Okay. Now you can see cos this x plus y by 2, they can cancel each other. 2 can cancel each other. You are left with sine x minus y by 2, cos x minus y by 2. That becomes nothing but tan x minus y by 2. That's your RHS. So again, this RHS can be given to you in form of options A, B, C, D. Okay. So far all the questions were pretty much straightforward. All right. Next question. Fourth. Now this time the problem is that you have a lot of cos and sine going on in the numerator as well as in the denominator. You have this first cos, this is second cos, this is third cos. Same with the denominator also. Sine, sine, sine. Now, of course, we know that if the question is given in the form of sum, we have to convert it in product. So that means C plus D we have to apply. But point is on which one? Should I apply on these first two? Or should I apply on the last two? This one, cos 3x, cos 2x. Or should I apply it on the first and last? Now for that we have to analyze that what can be generated. If I apply this on these two, so it will generate 4 plus 3, 7x by 2, 4 minus 3, x by 2. There is no such thing that is present here. So not too much beneficial. Let's apply on the first and last. Look at this. 4 plus 2, you'll get 6. 6 by 2 is 3. Now 3 angle is present in the middle. So if I apply on the first and last, the addition divided by 2 is generating the angle that is present in the middle. Same thing in the denominator also. If I apply on these two, 4 plus 2, 6. 6 divided by 2 is 3. So 3 is already present here. So it can generate some terms that is common. Okay. So that is the idea that you need to follow when you are given multiple terms. Make sure that you are getting pretty much same terms. So I'm applying on first and last. So basically cos 4x, I'm rearranging the term, cos 2x plus cos 3x. All right, sine 4x, sine 2x, sine 3x. Now apply on the first two here. Let's apply the property and see what is generated. So cos plus cos, so that will be 2 cos, addition by 2, 4 plus 2, 6 by 2, 3x, sine, not sine, cos, subtraction by 2, 4 minus 2, 2, 2 by 2, 1, so x. Of course, cos 3x is already in the addition. Same thing we have to do in the denominator, 2 sine, angle added, 4 plus 2, 6 by 2, 3x, cos, subtraction, 4 minus 2, 2, 2 by 2 is 1x. Now take common. You can see this cos 3x is common in this first two terms, same here. Sin 3x in common in the denominator. Let's take it common. This was the benefit that I was talking about, that we have to generate nearly the same term. So cos 3x, if I take common, this becomes 2 cos x plus 1. In the denominator sin 3x, if I take common, that generates 2 cos x plus 1. Both the terms are same, so cancel it. Cos by sin is cot 3x. That's your RHS. So we have proved it. Okay. So when you are given multiple terms, make sure that you are applying the property on which terms, so that something is generated which is pretty much already present there. So you can take common and simplify your expression. Of course, we can directly apply on the first two also, but that doesn't generate anything through which I can take anything common. So that's the key idea here. All right. Let's do the next one. Fifth. All right. Now for the fifth question, it's given to us that there is LHS cot 4x. So we cannot do anything right now with the cot 4x, let it be. But clearly this is sin C plus sin D. So I can apply this. So I'll apply 2 sine, angle added by 2, 5 plus 3, 8 by 2, 4x, cos, subtraction, 5 minus 3, 2, 2 by 2 is 1, cos x. Okay. Now maximum I can do is write cot 4x as cos 4x by sin 4x. I'll write it here only in the first step. Let's reduce the steps. Cos 4x by sin 4x. Now the benefit was that this sin 4x cancels. All I'm left with is 2 cos 4x cos x, and that's it. I cannot solve anything further in this LHS. Let's solve slightly RHS also. Cot x, I'll write cos x by sin x. And let's apply sin C minus sin D here. So that becomes 2 sine, subtraction, 5 minus 3, 2. 2 by 2 is 1. So sin x, cos, addition, 4 plus 3, 8, 8 by 4, 8 by 2 is 4x. Sin x cancel. So again I'm left with 2 cos x cos 4x. So clearly LHS and RHS are equal. If I solve one step of LHS and RHS, they are equal. So I've proved that these two expressions are also same. So sometimes you have to apply the property of addition and subtraction on both the sides also. Okay. All right. Done. So that was pretty much about C plus D and C minus D. Very straightforward questions. You will be able to identify them very simply here. All right. Now let's talk about multiple angles. So multiple angles, you will have a lot of properties. First, I'll discuss those properties. Let's start with sine 2a. So sine 2a is 2 sine a cos a. Okay. I can write in terms of theta also, but I'm writing in terms of a. So sine 2a is 2 sine a cos a. Okay. One more variation is, it is 2 tan a upon 1 plus tan square a. Now this variation may not be that much useful right now, but again I told you that some variations are important, so this will be very helpful in inverse trigo. This will be very helpful in when it comes in integration. So learn this. Okay, now this is sine 2a na? I'm writing sine a also. Suppose you have to convert sine a in half angle. Basically what is happening here, this angle 2a is becoming half. So if I want to break any angle in half, I have to use this property. So sine a, if I want to break in a half angle, I can write down this as 2 sine a by 2 cos a by 2 and this will become 2 tan a by 2 upon 1 plus tan square a by 2. Okay, so I'm writing both in terms of double 2a as well as a, both the identities, but get the idea. The idea is that every time you are writing an identity, the angle is becoming half. 2a becomes a becomes a by 2. Okay, next is cos 2a. Lot of formula for cos 2a. Simply put, this is cos square a minus sine square a. If I use the identity of 1 plus sine square theta plus cos square theta is equal to 1, or as we know that cos square theta is 1 minus sine square theta, if I use that, I can generate two more expressions, that is 2 cos square a minus 1 as well as 1 minus 2 sine square a. And then there is one more identity based on tan, so that is 1 minus tan square a upon 1 plus tan square a. Again, will not be using this last identity right now, but inverse trigo and integration, this will be helpful. Okay, all right, same thing I can write with cos a also, means again I'm doing half of the angle, so that will be cos square a by 2 minus sine square a by 2, 2 cos square a by 2 minus 1, 1 minus 2 sine square a by 2, 1 minus tan square a by 2 upon 1 plus tan square a by 2. Learn only the one that is present on the top, 2a1, but you should be able to comprehend the second one. Okay, all right, sine 2a done, cos 2a done. Let's do tan 2a also. Now tan 2a is 2 tan a upon 1 minus tan square a. No variation, directly this identity, tan 2a. Then you have the identity of sine of triple angle, sine 3a. This is 3 sine a minus 4 sine cube a. And then you have cos of triple angle, that is 4 cos cube a minus 3 sine a. Okay, so these are the identities relating with multiple angles. Double angle we have discussed, now triple angle we have also discussed. Tan 3 is also there, but very rarely used, so I'm not giving tan 3a. If it comes in any particular question, okay, then we'll discuss it there only, but it's a very lengthy identity and there is no point of using that. First of all, questions are more overly based on sine cos and few questions are based on tan. Okay, all right, now let's try to learn how to use these identities also. All right, first question, you have to prove cos 4x is this. Now cos 4x, first of all look at this angle, 4 times. Of course we cannot directly deal with 4, there is no such formula for 4. So what we can do is we can write this as cos of 2 times 2x, and for the time being treat this as a. So you'll see it is written as cos 2a. Now what is cos 2a? Now you have multiple identities of cos. Okay, look at here, lot of identities, but you see your RHS requires you to generate +1. Here +1 is generated. That means we'll use this one, 1 minus 2 sine square a. We'll use this. Let's generate it. See, idea is always very important to solve any question. That's why before applying any property, you should be able to identify why we are using any particular kind of property here. So this will be 1 minus 2 sine square a. A was 2x. I hope this is clear. First step, why we are generating. So at least something is generated for this. Now I can do is use the property of sine 2x. I'll rewrite this first of all, 1 minus 2 sine 2x. This is whole square, na? Basically sine square means this. Now use the property of sine 2x, that is 2 sine x cos x, and there is a whole square. Now do the squaring, 1 minus 2, this will become 4 sine square x cos square x. So that becomes 1 minus 8 sine square x cos square x. That's your RHS. Okay. If you look at the whole question, this first step was the key idea, that which identity I have to use, because there is a lot of formula for cos of double angle. But which one I used? I used the one which generated this one. So sometimes the question indirectly will give you a hint that which step you need to follow. Okay. So this is one way to apply these identities, combining them. Okay. Let's do one more. Next one, second. Now this time you have to prove tan 4x as something. Okay. So again we'll use the same idea, double of double. So I'll write first of all tan of 4x as 2 times 2x, and this will be my a. So you'll read it like tan 2a. Now the formula is 2 tan a, which is 2x, upon 1 minus tan square 2x. And then again I'll apply the expansion of tan 2x, tan 2x. So let's apply it. So numerator will become 2 bracket 2 tan x upon 1 minus tan square x. Okay. This was the identity, upon 1 minus 2 tan x upon 1 minus tan square x, and there's a whole square present in the denominator. Tan square is there, na? This one. Square is also present, na? So this square is present here. So numerator will become 4 tan x. Okay, something is generated, na? 4 tan x is already there, so fine, at least something is generated. 4 tan x upon 1 minus tan square x. Denominator I'll have to square it, so 1 minus 2 tan x, na? So square it, 4 tan square x upon 1 minus tan square x whole square is there. All right, now let's solve. I'll take the LCM in the denominator first of all here, and take the denominator in the numerator. So this becomes 4 tan x 1 minus tan square x upon if I take the LCM in the denominator, this becomes 1 minus tan square x whole square minus 4 tan square x upon 1 minus tan square x whole square. Now let's reciprocal it. 4 tan x 1 minus tan square x, and this will become reciprocal, so 1 minus tan square x whole square, 1 minus tan square x whole square minus 4 tan square x. Now the benefit of not opening this whole square in the denominator was this cancels this one power, so that generates 4 tan x 1 minus tan square x upon, and this time now we'll look at the RHS now. 4 tan x is generated, this one is also generated, denominator there is power 4, so that means we have to open the whole square. So let's open it. So 1 square plus tan square square means tan ki power 4x minus 2 tan square x minus 4 tan square x. So that I think generates 4 tan x 1 minus tan square x upon 1 plus tan raised to power 4x minus 6 tan square x, and that's your RHS. Okay. So that was the idea. We opened it with 2 times 2x. 2x we called it as a, so I used the property of tan 2a, opened it, and then again tan 2x was there and I converted in tan x using the same identity again, and then just some mathematical manipulation and done. So how you open it, it depends a lot. If I open the whole square in the denominator, this one, it will become complicated, so I opened it only at the last step. Before that I didn't open it. Okay, and that gave me this benefit, that's 1 minus tan square, and this 1 minus tan square whole square got cancelled. So be very careful while opening any identities in Trigo. Okay. All right. This question is also actually lengthy from conventional point of view, but you should be able to understand how the properties are being applied. So I'll discuss this one also. This is question number 2 and 3. This time you have to prove 6x. Now not even 4, this time is asking you to do 6x. So there are two ways to do this question. Either you can write this is cos of 3 times 2x, or you can write cos of 2 times 3x. Any one you can use to open it. I'm using this one. So or we can use this one, 2 times 2 cos square. Both will generate some complication anyways. Let's use this one since I've told this one. You can try this one on your own. Okay. So this is our a. Okay, cos 3a. The formula for cos 3a is 4 cos cube a, which is 2x, minus 3 cos a, which is again 2x. And then use the property of double angle. Cos 2x, this is 4 cos 2x. Okay, which one I have to use? The point is, now cos, if you remember, cos has multiple identity. Cos 2x is cos square minus sine square. It is also 2 cos square x minus 1. It is also 1 minus 2 sine square, and then there is one more with the tan. Now which one should I use? I'll use the one in which cos is there, because look at your RHS. Your RHS has only cos terms. That means we have to use the identity of only cos. So I'm using this one, second one. So I'm using 2 cos square x minus 1, and there is cube of it, minus 3 into 2 cos square x minus 1. Now let's open the cube. So 4 times, this is a minus b whole cube. Okay, so a cube, that is 8 cos square cube is cos 6x, plus b cube, that is 1, minus 3 into a into b, 3ab bracket, so a cube minus b cube, so a cube minus b cube, minus 3ab bracket a minus b, 2 cos square x minus 1, minus 6 cos square x plus 3. I've multiplied these, 3 to the 6, 3 into 1 is 1. Now let's multiply 8 for 32 cos raised to power 6x minus this becomes 4, minus this becomes 3 to the 6, so 24 cos square x bracket 2 cos square x minus 1 minus 6 cos square x plus 3. So 32 is generated first of all in the question, that is there, 32 cos raised to power 6x minus 4 minus, let's multiply, 24 into 2 is 48 cos raised to power 4x minus 24 minus 1 plus 24 cos square x minus 6 cos square x plus 3. Now let's deal with the numbers. This one and this one we have to solve, this one and this one we have to solve, rest everything is solved here. So 32 cos raised to power 6x minus 48 cos raised to power 4x this becomes 24 minus 6 becomes 18, plus 18 cos raised to power 2x plus minus 4 plus 1 becomes minus 1, and that's your RHS. Okay, so whenever you are applying any property, make sure that you know which one expansion should you use, because a lot of identities are there for cos specifically. So the question RHS will tell you which one you have to use. Okay, all right, okay, this is done. Last one, this one is pretty simple as such, but I'll discuss it with the identity with the removal of square. I'll not discuss it here, so let it be. Okay, because I have to show you the variation of the identities, the same one, cos 2x, because cos 2 have a lot of identities, so a lot of variations are also there. So that one I'll discuss with the removal of square. Okay, so one variation that we'll cover later in the next lecture effectively. Okay, let's do this one, product to sum. This one is okay. All right, so first of all, so far we learned C plus D identity, na? Like sum was there, sin C plus sin D was there, or cos C plus cos D were there, and we were converting into 2 sin cos, cos sin, sin sin, cos cos. So basically we were generating sum to product. Now we have to do the reverse. We have to generate product to sum. So again, few more formulas. That's why I'm categorizing them, not giving you all the formulas in one go. So the first formula is 2 sin A cos B. This is equal to sine of A plus B plus sine of A minus B. Okay. Same way you can use 2 cos A sin B also, but my recommendation is only learn this one, because this will effectively deal with the second one also. So no need to learn it, but I'm giving you the formula anyway. This is sine A minus B, sorry, sine A plus B minus sine A minus B. Then you have 2 sine A sine B This is cos a minus b minus cos a plus b and 2 cos a cos b. This is cos of a minus b plus cos of a plus b. Okay, all right. Now let's see what kind of questions are there and how do we apply this property, and more importantly, how do we know that this property is being used. Look at the question will tell you. I told you. I will let the identities to be on the screen so that you can easily apply it. First of all, look at the question. It is in the product form already. Cos, they are being multiplied. Again, cos, they are being multiplied. You have to generate something, and this should be your RHS. Fine, let it be. But your LHS is already in the product form if you look at the terms. So I cannot use any other identity right now. I have to use, this is in the product form. If the question is in the product form, you generate it to sum or difference. Okay, so I have to convert it product to sum. Let's do it. This is cos A cos B. Okay, but look at the identity. The identity is for 2 cos A cos B. So what we can do is I will multiply and divide the expression with 2. So cos, I'll rewrite this, cos 2x cos x by 2 minus cos 3x cos 9x by 2. First of all, 2 is not there, so let's multiply it by 2. So I'm multiplying both the expression by 2, so I have to divide the whole expression also by 2 so that the question remains same. Now we can apply 2 cos A cos B. Look at the identity. 2 cos A cos B is cos A minus B plus cos A plus B, means cos of, one time you have to add the angle, 2x plus x by 2, that becomes 5x by 2. Okay, plus cos of subtraction, 2x minus x by 2, 3x by 2. Okay, whether I'm writing a minus b first or a plus b first doesn't matter because addition is going on. Minus, again same thing, cos, first add them. So 9, 3 to 6, 6 plus 5, 15x by 2 plus subtract cos, if we subtract 3 to 6, 6 minus 3 is, sorry, 6 minus 9 is minus 3x by 2. If you apply the property A and B here, cos A cos B, 2 cos A cos B, subtraction will generate a negative. No need to worry about the negative. We'll use the negative property of cos and sine. In the cos, I told you that this negative has no effect. So we can remove this negative. So I'll remove it in the next step. Okay, so this is 1 by 2. This is the whole expression. So that is cos 5x by 2 plus cos 3x by 2 minus cos 15x by 2 minus cos, this, remember this negative is because of this one. This one will be multiplied here. Okay, and this negative actually gets removed, 3x by 2. This cos 3x by 2, cos 3x by 2 cancels, and now simply last step, cos c minus cos d is applicable here, so apply that. 2 cos c minus cos d is minus 2 sine c plus d by 2, add them, 5x plus 15x, 20, 20 by 2, 10, 10 by 2, 5x, sine 5x, sine, subtract them, 5 minus 15 minus 10 by 2 minus 5 by 2 is minus 5x by 2. Okay, just apply sine c minus sine d here. Sorry, cos c minus cos d. Okay, so this generates this expression. So first of all, this 2 and 2 cancels. In the trigo of sine, sine of minus theta is minus sine theta, whereas cos of minus theta is cos theta. So in sine, this negative will come out. If this negative comes out, it will cancel this one. Okay, so what we are left with is sine 5x into sine 5x by 2. That's your RHS. Okay, so the question will always tell you whether you have to use sum to product, product to sum itself. Let's look one more last example. Look at this question, second one. Look at this, 2 cos, some angle is there. It's not a standard angle because it is pi by 13, 9 pi by 13. Let it be. But this one is okay. So this is in the form of product. I cannot do anything with the product first of all. So what I have to do, I have to convert this product to sum or difference. So let's apply this cos A cos B. Okay, and for simplicity, if you want, what you can do is always take A which is bigger one, so you will not get negative generated. So it's not a compulsion that the first one has to be A. You can take this one as A and this one as B, because in the product doesn't matter now which one is written first. So 2 cos A cos B is cos of A minus B, so 9 pi minus pi, so 8 pi by 13 plus cos of addition 9 pi plus 1 pi 10 pi by 13 directly. Let all the terms be same, 13 cos 5 pi by 5 pi by 13 equal to 0. Now this is where an identity that I told you that some important result was there in supplementary angles. When we were talking about angles, I told you that if at A plus B is 180 degree or pi, cos A plus cos B is 0. I told you this. Okay, why it is happening? Because if you remove this cos A, you can write cos B as cos of pi minus A, and you apply the property cos A 180, there is no change, so let it be cos. In second quadrant, cos is negative. Cos A minus cos A becomes 0. So if the two angles sum is pi, I can say the cos addition will cancel. Look at this. This is 13. Okay, look at these two angles. Their addition is pi. Same with this one. Look at these two angles, 8 pi by 13 and 5 pi by 13. If you add them, their addition is pi. If their addition is pi, the sum of their cos must be 0. Okay, so I can directly cancel this using the property that I told you, that these two will cancel. Similarly, these two will also cancel. Okay, hence they are 0 is equal to 0. We have proved it. This is what we had to prove now. So we proved it. But remember this identity. For this, you need to know this, that the sum of two angle is pi, then cos A plus cos B is 0. Okay. All right. So pretty much I'll say 90% of our properties are covered. Now, no more new identities, but the identities of cos, we have a lot of formulas. So I'll talk about the variation which is used in trigo also, and that particular variation again will be repeated in inverse trigo, will be repeated in limits, will be repeated in your integration. So next class, the identity that we'll talk about is very, very crucial. Any question that has to be from examination point of view, if I want to make any question complicated, he will be using that kind of identity. Okay, these are pretty much standard, but that one is a variation, so variations are always recommended. Okay, all right, that's it for today's class. See you in the next class. Good day, everyone.